Hi, my name is Walker Daniel, and today I'll be presenting my lab for bar magnet vision. In this experiment, we were tasked to find the magnetic field caused by the bar magnets at different distances and positions on an XY axis. We then used a Biot-Savart to calculate the law to calculate the numerical dipole magnetic field. The goal was to determine the magnetic fields caused by the bar magnets. Results show that the bar magnetic field goes from south to north, and as it goes further, the smaller the field power has. First, we need to download the magnetic meter in order to start this experiment. Then we had to create an XY axis with rulers and tape on the phone so that the 00 was the neutral natural magnetic force of the Earth, and the tape acted so that we knew exactly where our 0 was on the phone. Next, the phone was placed at different places along the X and Y axis in order to, and the fields were jotted down. We then plugged in all our data for calculations, as we'll see in a few minutes. This is the data we received. As you can see, we calculated each different spot 3 times. So R20, R70, R120, R170, R220, we each did that 3 times by refreshing the app to make sure the data was consistent. Then we did some off-centered field things down here, and then finally the averages are right here. And then we used this formula here to create to do some calculations or a modification. I did the R squared vector form or R cubed vector form instead, but same premise. In order to find our unknowns, as you can see here, it was one or 12.5 AM squared. Then for our coding, we were supposed to change certain position vectors and add a little data, but I don't really have the images for the code here because I didn't really find it super important. But here we can see that it looks a lot like a magnetic field that resembles a dipole, which is very interesting. Of course, my data isn't perfect. There are some possible errors for human errors. I mean, moving the phone perfectly to each thing and getting the exact readings is kind of difficult. There's also calculation errors. We're working with some interesting numbers, so that could always um, be a source of error. There might be some rounding errors. We're using lots of really big and small numbers, so it's hard to know exactly what is what. And then finally, there's could be some outside effects such as computers on the data, which can distort the magnetic fields and make our data inaccurate. Also, we could have not had it perfectly north south. And then finally, here's some discussions. What if you hadn't orientated your experiment to compensate for magnetic north and instead laid your meter stick at some intermediate angle with respect to Earth's magnetic fields? How would the results change? Well, the Earth's magnetic field would affect the data, creating a sloping effect on the field readings, which essentially means that the data would be skewed in some way, um, that the magnetic north would have some whatever angle would kind of distort the values or skew the values. Then what if you're just stick two identical magnets end to end and run the experiment again? How would this expect to change your measurements? And the number would be roughly doubled because B would be oriented in the same direction, thus creating a larger magnetic field and making the readings a lot larger. That is all I have. Thank you so much.